Bismillah. This is the explanation of text 2, work and inner energy. Okay, number 1, an ideal gas with volume of 3 liters. In here we have volume, the first volume 3 liters with temperature 127 degrees Celsius, and the gas is heated at a constant pressure. Berarti P-nya konstan, temperaturnya konstan, isobarik to atmosphere, and until the temperature reaches, okay, the second temperature is 227 degrees Celsius. Okay, if 1 atmosphere. Okay, don't forget to use international units, so you must change like liter to meter cubic first, Celsius to Kelvin, atmosphere to Pascal, Celsius to Kelvin. Okay, so 3 liter equals 3 times 10 negative 3. This is 300 Kelvin. Don't forget, Celsius to Kelvin, you have to plus 273. Okay, 2 atmosphere, so it will be, if 1 atmosphere 1.03, so 2 atmosphere must be 2.06, right? Times 10 power of 5. And this is plus 273, it will be 500 Kelvin. Okay, the formula of work. The question is the work done by the gas is, okay, the question of work equals formula. The formula of work is pressure times delta V. So this will be pressure times second volume minus the first one. And right, and okay, this is the formula of isobaric. Okay, the second volume we don't have yet, so we have to find out first. Use this. Don't forget the basic formula for gas, that is gas ideal equation. The pressure 1, volume 1 divided temperature 1 equals to pressure 2, volume 2 divided temperature 2, gitu ya. Because this is constant pressure, so barik, you don't have to think about the pressure, just divide both of them. The first volume is 3 times 10 negative 3. The first temperature is 300 divided volume 2. The second volume and the temperature is 500. Okay, coret. Okay, the second volume is 5 divided 10 negative 3 meter cubic. So we have all we need. Pressure is 2.06, then negative 5, positive 5. The second volume is 5, negative 3 minus 3, 10 negative 3. Alright, just put the number. Okay, result, we got 2 times 2, 4, 6 times 2, 12. Alright. Plus 5 minus 3, positive 2. So it will be 412 joule. Energy, the unit is joule. This is the answer. Next, number 2. The work produced in this cycle. Okay, kalau mencari, if you have to find work all cycle, you can use Lewis graphic. So the work is Lewis graphic, that is like rectangle, ya. Okay. Panjang kali lebar, that's it. Okay, for panjang berapa? Let's use this 1 to 3. So it will be 2 times the lebar, 2, 10.5. So the result is 4, 10.5 joule. Okay, change to kilojoule, it will be 400 kilojoule. So easy, yeah. So if you want to find out the work all cycle, full of the cycle process, you just use the Luas graphic. Number 3, okay, the graph pressure and volume graph below shows the heating process of an ideal gas. The amount of work done in cycle ABC. Okay, cycle A, B, C only. Nah, nggak semua ya. Not all, just A, B, C. Not A, B, C, A. No. Okay, so work ABC process, we have to find work at AB plus work at BC. AB to BC. Because AB is isothermic, it kind of not simple and it takes time. I'm going to show you the second way. Okay, you can use work ABC equals to ABC equals to ABCA, ABCA, all of it, yeah, all the processes, minus, okay, minus ABC, okay, yang nggak include, not include is this one, C to A is not include, yep, so we can use work of ABCA minus work of CA, okay. Okay, this is luas grafik. Ya, kan semuanya ya. Luas grafik half. Oke, setengah alas kali tinggi minus C ke A, dia isobarik ya. That's isobarik, so we can use pressure times delta V. Okay, just that's it. Okay, the result is half times alas, let's say oke, alasnya 100 ke 600, alasnya berarti 500 ya. Tinggi 200 ke 400, berarti 200 minus pressure-nya di 200 ya, di 200, 200, ke delta V, don't forget, second volume minus the first one. It's going to be 5, 1, 2, 3, 4, okay, 50 hundreds, 50,000, I'm sorry, 50,000 minus 200 times the second volume. Okay, looks the arrow. Okay, C to A. So the second volume is 100 minus 600. The result is 50,000 minus, okay, minus, this is, how much is it? 200, this is minus 500. So the result is 50,000 plus, minus to minus plus, 2 times 5, 10, 1, 2, 3, 4, okay, 100,000, that's it. Okay, the result is 150 joule. Change to kilojoule, it will be what? 150 kilojoule. Okay. Volume diagram below, the following statements that is true. Okay, number 1, the amount of inner energy in the ABC and CTA processes is different. Okay, the verb is here, and this is the preposition, this is the subject, this is the noun. Oke, jadi intinya di soal ini adalah nyari amount-nya, nilainya. Apakah beda atau apakah sama? A, B, C, dan C, D, A. Pertama, you have to see the cycle, the process. A, B, isobarik. C, D, isobarik. B, C, isochoric. D, A, isochoric. Right? Yap. Cek panahnya. Yang ini A ke B membesar volumenya, B ke C membesar pressure-nya. If volume or pressure gets bigger, it means the process is in expansion. Berarti dia expansion, gitu ya. Dia menerima panas. The process absorb heat. Berarti ini dia proses Q-nya absorb, and those process also do the work. Jadi dua-duanya positif. And CD and DA, the volume is is compressed. Compressed ya, compression. D2A compressed as well. Nah, it means the system is release heat, yang melepaskan panas. Worknya juga negatif, gitu. Nah, tapi kalau dari angka akan sama. Why? Because the process with the same number. Gitu ya. So this is wrong. The work is equal to 0? No, absolutely no. The work is equal to 0 if that process only isochoric. But A, B, C, we have isobaric ya. So it will not 0. Okay, the third, okay, the system absorb heat A, B, C, that's right. And the C, D, A, release it, all right. Yeah, the result is A, E. Okay, number 5, the first law of thermodynamics states that, all right, hukum 1 termodinamika. Okay, the energy is conserved. Okay, hukum kekayaan energi ya. The energy cannot be created nor be erased. Yeah, the energy only can be changed to another form. Gitu ya, energi itu kekal. Itu hukum satunya ya. Jadi, oke. Ada yang lepas, ada yang masuk. Tuh. Nilainya akan kekal. Jadi tidak ada yang hilang dan tidak bisa juga dibuat. Number 6. Which statement is true about thermodynamics processes? Langsung aja. The result, the answer is A. Isobaric is process of changing gas at constant pressure. Next. Number 7. A system experiences an adiabatic processes. Don't forget, in adiabatic process, the system did not receive or release heat. So, the heat will be 0. Jadi dalam adiabatik tidak ada proses penyerapan atau pelepasan kalor ya. The system does work. So, because the system does work, the work is positive. If the change in internal energy is delta U and the heat absorbed by the system is Q, Q is positive because absorb, diserap ya. Then don't forget, okay, I will show you again. Okay, let's say this is the system, will be delta U, and if you eat, let's say Q as food, if you eat, the food will be positive, and if you throw up, for example, or you release the food, the heat will be negative. And if you do the work will be positive. If you get work from environment in here, the work will be negative. Okay, that's the point. All right, then, okay, how about the formula? The Q equals with delta U and work. Okay, this is the formula. Heat equals with inner energy delta U plus work. Okay, the heat is 0 because of adiabatic process, delta U plus 200. So delta U will be minus 200. That is the answer. Okay, next. An amount 100 joule of heat is added. Ditambahkan, berarti 100-nya in positive. And 400 joules work are done. Dia melakukan kerja. Are done. Telah dilaksanakan gitu lah ya. Work-nya 40 joules, berarti positif. What is the magnitude of the increase of internal energy? The formula is Q equals with delta U plus work. Delta U will be Q minus work, right? Q minus work. Q is 100 and work is 40. The result is 60. Okay, this is the answer. Number 9. The gas in a heat engine expands. Constant pressure. We have pressure constant 100 kilopascal. And the system absorbs heat. It will be positive because absorb, yeah. The volume of gas expands. Okay, the first volume is 1.15 meter cubic. The second volume is 0.25 meter cubic. The question is the amount of work and the internal energy. Alright, langsung yang work dulu ya. Isobaric, right? Constant pressure. Isobaric. The formula is work equals pressure times delta V. The pressure, change to Pascal, it will be 100, 1, 2, 3, 100,000 Pascal. Then 1, 2, 3, 4, 5, 5. Delta V 0.25 minus 0.15. The result is 0.10. 10 of 4. How much is it? Okay, it will be 1/10 of 4. Yep. Ini satu ya. Ini kan kalau 0,10, ini yang 0 belakang ini nggak usah dimasukin. Juga nggak apa-apa ya. Okay. Terus, and then the change in internal energy, delta U. The second one is delta U. Berarti satu antara ini atau ini ya. Delta U is Q minus work. Q in here 2.10 power of 4 minus 1. This is 4. The result is 1.10 10 power of 4 joule. This is the result. That's the answer. Next, the last one. A monoatomic gas. Kayak monoatomik ya, yang satu atom kayak C, karbon, hidrogen, O, satu atom. Kalau ada diatomik berarti maksudnya kayak ini yang dua atom seperti CO2, for example. Jadi ada dua atom gitu ya, bentuknya, bentuk wujud gasnya. Okay. A monoatomic gas in an enclosed room has a pressure. In here we have pressure 1.210 power of 5 Pascal and the volume is 40 liters. If the gas expands at isobaric process, so the volume increases by 10 liters. Okay, so the second volume will be 50 liters, right? Because dia nambah increases by 10 liters. Dia nambah 10 berarti 50 gitu ya. The gas will absorb heat, okay, heat which is 2.10 power of 3 joule absorb, so it will be positive. Okay, at the end of process, gas temperature will increase. True or false? Number 10. Okay, the first one you have to, let's find out. Okay, yang bisa dulu aja. Work pressure times delta V. Pressure is 1.2, 10 power of 5. Delta V is 10 liter, 10 negative 3. So the result is 12 times 10 of 2 joule. It will be 1200, right? Okay, this is right. Number 2 is true. Okay, the change in internal energy. Delta U. Delta U is Q minus work. Heat is 2, 10 power of 3 minus 1.2, 10 of 3. It will be 0.8 or 800 joule. This is also right. Okay, gas temperature. If you have inner energy with positive, this is positive, right? It means the temperature is increased. Okay, that will answer number 1. Okay. If the inner energy is positive, it means the temperature will increase. This is true. Okay, the fourth, density of gas increases. Density, massa jenis, or with symbol rho, which is mass per volume, right? Because the volume is increases, nambah nih, it means the density will be decreases. Dia berbanding terbalik ya, so it will wrong. The result is decreases. The answer is decreases ya, karena ini berkebalikan dia. So the result, the answer is number A. 1, 2, 3, correct.